Hello, my name's Craig McNeil. I'm a lecturer in theoretical physics and I teach on Physics 1. I'm part of the teaching team of that module. So in this video, I'm just going to give you a short overview of the content of the module. Okay, so now we come to just a short overview of what Physics 1 actually is. So there are two physics modules on the foundation year, Phys 050, which I'm part of the teaching team in semester 1. Essentially that teaches heat and thermodynamics, waves, light, stresses and strain. And then the second semester, my colleague Vincent Drack would teach electricity, electromagnetic fields, radiation, and a little bit of astronomy. Overall content would be similar to what is covered in A-level physics. Physics is really the basic language of the universe and engineering, and we just aim to cover the basic language and use some of the basic equations, and from that you can kind of build on additional engineering applications as you progress during the degree. So just a kind of slightly more detailed syllabus. We start off with just numbers, scientific notation, SI units, meters, grams, stuff like that, and how to convert between the different units, and then go into energy, density, energy and power, structure of matter, it's just atoms, and then heat and thermodynamics, stress and strain, what happens when you stretch a material, and then there's a kind of, waves are a very important concept throughout physics and engineering, so we just go over the basics with applications of sound and light waves, stationary waves, lenses, a bit of geometric optics, some physics on the static fluids, and then do look at gas laws and thermodynamics again, and then end with some work on estimation and modeling, which kind of integrates all the different things we've done before. Okay, and all the material we put on the DLE, there's a kind of reading list, and there's printed notes on there as well. So how's the module assessed? There'll be a kind of exam component, which is 40% this time. It will be a kind of a take-home exam. You have a couple of days to do it, and it'll be similar in format to previous years, 15 questions. The remaining part of the assessment is done by coursework. There are online quizzes, which is worth 30% of the overall module mark. The deadline is January, so I usually typically put out 4 questions a week for about 8 weeks, and there's a single deadline in January. There's a sort of experimental coursework which we've done in small groups of 3 or 4 students, and that's broken down to tasks. There'll be a measurement project, 3 kind of simulations, a video analysis project, and using a mobile phone project, using the sensors in your mobile phone. And there's one deadline for this, it'll be the end of this year. To pass the module, you need to get 40%. You need to get greater than 40% of the total mark. However, to progress usually to the engineering degree of your choice, you need a higher overall percentage. Okay, so this is just to give you an idea of what the kind of experimental component is. Also, it's slightly different to get lab access this first semester. So here is a basic simulation of a physics thing. So a laser light goes from one material into another material, and some part of the light is reflected and part of the light travels through. So there are kind of equations for how these the angles work. You can kind of do measurements and change the material. So it's a way of sort of mapping out the laws of physics with these kind of simple computer simulations. Also, we're looking at the analysis of videos. We're not going to actually use the example. It'll be an example, probably oscillations or waves, and essentially you can kind of map out the motion. So obviously we have a video, we want to kind of convert that into kind of maths to map it out, and we can kind of click on it. I'm doing this very crudely. So it takes a measurement of the positions where it is in the XY plane, and you have the times, so you can get velocities. And so you can actually kind of convert the video when it's properly calibrated into a way to analyze the motion in terms of position and velocities, and that gives you some information on the kind of dynamics. So that's one of the kind of things we're going to do as part of the sort of experimental kind of data analysis type part of the physics module.